Hello, and thank you for taking the time to learn about PPACT Studio. PPACT Studio is an engineering intelligence platform for early-stage AI system architecture exploration. The idea is simple, but this step is often missing from early-stage design workflows. Make the architecture decision before you build it. Before committing to RTL, detailed simulation, or implementation, engineers should be able to compare alternatives, understand system-level consequences, and explain why one architecture is more suitable for a given set of constraints. PPACT Studio is designed to support this process by comparing alternatives, explaining the engineering consequences, and helping engineers make informed architecture decisions. Let me begin with what the platform actually does. You provide the architecture to be evaluated, including the host CPU, memory system, accelerator, workload, process node, numerical precision, and design constraints. PPACT Studio then constructs a system flow map. The platform does not treat CPU, memory, and accelerator metrics as isolated numbers. It evaluates them as an interacting system of engineering trade-offs. From the same analysis, it produces measured results, architecture balance, recommendations, and an engineering takeaway. For example, faster memory may reduce a memory bottleneck, but that does not necessarily remove the system bottleneck. The limiting stage may simply move to the host. The objective is not just to produce more numbers. It is to show what those numbers mean for the architecture. Architecture exploration becomes difficult very quickly, even with only 5 decisions: process node, compute architecture, memory, precision, and batch size. We already have hundreds of possible combinations. But the harder problem is not simply the number of choices. The system-level result can be counterintuitive. Study 001 demonstrates this clearly. We increase memory bandwidth by a factor of 16. Intuitively, we might expect a dramatic improvement. Instead, pipeline capacity improves by only about 17%, while system cost increases by roughly 12 times. Why? Because memory was not the fundamental limiting element. This is the problem PPACT Studio is designed to address. The purpose is not simply to calculate metrics. It is to identify which architectural decision deserves attention next. Today, much of early architecture exploration is iterative and fragmented. Engineers select specifications, run estimates or simulations, move results into spreadsheets, compare alternatives, and then repeat the process. PPACT Studio reorganizes that workflow around one engineering question and one traceable analytical pass. The same inputs drive analytical evaluation, comparison, recommendation, visualization, and finally, the engineering review. The goal is not to eliminate engineering judgment. Quite the opposite. The goal is to give engineering judgment a consistent body of evidence. So instead of moving from one estimate to another without a common framework, we move from guess to evidence. This leads to one of the most important characteristics of PPACT Studio. It does not simply score a design. It explains why. On the left, the system flow map shows how the limiting element changes between architectures. On the right, recommendations are classified and traced back to the engineering rules that produce them. A proposal can be direct, contextual, or contrasting. If a rule conflicts with the proposal, that rule can be excluded, and the exclusion is recorded. This distinction is important. PPACT Studio does not claim to predict the exact quantitative impact of a proposed change before evaluating the changed architecture. It identifies a structurally justified change. Then the modified architecture is evaluated and the result is measured. Every recommendation, therefore, comes with an engineering reason, while the quantitative impact of the change is established by evaluation rather than assumed in advance. Architecture optimization is rarely about maximizing one metric. Study 001 is a good example. With the faster memory configuration, latency decreases from 11.52 to 9.81 milliseconds. Pipeline capacity increases from 118.01 to 137.54 inferences per second. Delivered throughput, however, remains at 60 inferences per second because the application target already caps it at that value. Now consider the other side of the decision. System power increases by 276%. Thermal power density increases by 554%. and system cost increases by more than 1,000%. The design still meets its thermal constraint, but the improvement comes with substantial power and cost trade-offs. 16 times the memory bandwidth provides about 17% more pipeline capacity at roughly 12 times the system cost. That is the reality of system bottlenecks, and that is the kind of trade-off an architecture review needs to expose. For an engineering platform, useful output is not enough. The output also has to be trustworthy. So validation is part of the product architecture. The current build has passed 5,128 model checks, 6,218 freeze checks, and 3,399 interface checks. It also includes 162 registered mutation tests, with 0 planted defects surviving, and 156 independent arithmetic checks recomputed outside the engine. All 15 architecture studies run through the same engine. But I want to be equally clear about what has not yet been established. Measured hardware accuracy, educational effectiveness, independent external validation, and commercial product equivalence remain open validation areas. We document those limitations explicitly, because a validation report that only tells you what passed is not really validation. It is advertising. Our objective is to make trust something that is engineered, traceable, and auditable. The primary customer we envision is an architecture team in the semiconductor or AI accelerator industry. These teams need to narrow large design spaces before RTL exists, compare alternatives during design review, and justify why a particular specification was selected. The economic argument is straightforward. PPACT Studio should not be evaluated only against the price of another software tool. It should also be evaluated against the engineering cost and schedule impact of an architectural decision that later requires major redesign. Education is a secondary audience, but an important adoption channel. Engineers can learn the methodology before entering an organization and then bring that workflow into the engineering team. The engineering team is the primary customer. Education helps develop future users. PPACT Studio is not intended to replace detailed simulation or EDA tools. It occupies a different stage of the engineering process. Spreadsheets are fast, but system-level reasoning is largely manual. Detailed simulators provide deeper modeling, but require more setup and are slower to apply across a large design space. EDA tools become essential as the design approaches implementation. PPACT Studio sits between those stages. It is intended for fast architecture exploration, system-level trade-off analysis, bottleneck reasoning, and rule-traceable recommendations without requiring RTL. Importantly, we do not claim detailed simulator accuracy. The philosophy is simple. Explore broadly first, and use deeper simulation when the evidence indicates that more detailed analysis is needed. PPACT Studio is already running as a public preview. There is no installation and no account requirement. The studies run directly in a browser. The current library contains 15 architecture studies. They examine practical questions such as whether faster memory improves the system, whether a larger engine always runs faster, whether 2 engines are better than 1, and whether moving to a finer process node actually improves the overall design. These are not pre-rendered demonstrations. The results are generated by the engine when each study runs. Study 001 is also available as an end-to-end engineering walkthrough, so our invitation is simple. Don't take our word for it. Run Study 001. The roadmap is deliberately validation-driven rather than feature-driven. Today, the public preview provides 15 live architecture studies and a browser-based workflow. The next phase focuses on evidence from real use, observing how engineers use the platform, incorporating feedback from real exploration work, closing the remaining validation gaps, and expanding the study library. Version 1.0 is reached only when the defined review requirements are satisfied, coefficients have been checked against measured data, and the reproducibility record is ready. Beyond that comes enterprise validation, partner workflows, team licensing, and domain-specific study libraries. We do not want release milestones to depend only on arbitrary calendar dates. Each phase should close when its defined engineering validation requirements are satisfied. As PPACT Studio develops, we are also exploring how it could support engineering teams in practice. Because architecture decisions are usually collaborative, a team-based model may ultimately be more appropriate than individual access. The potential value lies in giving a team a common analytical framework for architecture exploration and design review. Such a model could bring together platform access, validated studies, engineering review outputs, and validation records within a shared workflow. At the public preview stage, however, our priority is not pricing or a fixed commercial model. We first want to understand how engineers actually use PPACT Studio, which studies provide the greatest value and where the platform needs further improvement. There is also a longer-term opportunity for the study library to grow through real engineering questions. As new studies are validated and added, the platform can gradually become useful across a broader range of architecture decisions. For now, the priority is to validate the engineering value first and allow an appropriate business model to develop from real use. At this stage, PPACT Studio is still evolving through engineering validation and feedback from real use. We are interested in hearing from engineers, researchers, and teams who are exploring system architecture decisions of their own. Real engineering questions can help us understand where the platform is useful, where its assumptions need to be refined, and which kinds of studies should be explored next. When appropriate, these questions may also lead to new validated studies and help broaden the PPACT Studio study library. If you would like to explore the platform, Study 001 is a good place to begin. We invite you to try PPACT Studio, examine the results, and share your engineering perspective with us. Each piece of feedback can help us improve the platform and strengthen its engineering foundation as we move toward version 1.0. Thank you for your time and interest in PPACT Studio.